getting onto transformations. So there are a few different types of transformations. This is really important stuff. Make sure you take note of this because we do go into it in a lot of detail in Unit 2, especially when you're getting into trig functions, but then it's also really important for Year 12 as well. So a dilation is where you multiply a function by a constant number. So this is, well, there's two types of dilations. The first type is where you multiply the function by a constant number. And what this basically does is it determines how kind of wide or skinny a function is. We'll get into an example of this in a second. But if a is greater than 1, then it's going to stretch it. It's going to make it wider, right? Because for every y value, we're making the x values bigger, right? So, and then if a is between 0 and 1, we are going to shrink it. So, then for our second type of dilation, we are going to have a b value within the x. So for this one here, if a is greater than 1, then it's going to shrink it, or if a is between 0 and 1, it's going to stretch it horizontally. So, as you can see, as I guess as makes sense, if you are making the x values bigger by multiplying them by b, then for like every y value, everything is going to be like shrunk inwards because the x values are changing. And then getting onto reflections. So if you make a function negative by putting a negative at the front, then you're going to reflect it over the x-axis because you're saying that although the x values are going to be the same for every one of those x values, the y value is now going to be the negative of what it was before. A translation. So if you add a constant to every single x value, you're going to shift it horizontally. So a change within the x value is a shift horizontally. A change separate to the x value, if you're just adding a constant on the end, is going to be a shift vertically. So where this horizontal translation gets tricky is if you are, or I guess kind of like maybe intuitively, if you add a positive number, it's going to shift the function to the left. But if you add a negative number, it's going to shift the function to the right. So it's kind of like the opposite of what you'd expect. But then with our vertical shift, if you add a positive number, it's going to move it up. If you add a negative number, it's going to move it down. So as you can see here, if our original function is x squared, if we multiply our original function by 2 out the front, this is going to be our first type of dilation. We are going to change it, and then if we do the second type of dilation, we're multiplying within the x. So as you can see, when we apply the dilation in our second example, the curve is going to become skinnier. It's going to be like shrunk horizontally. Now, if you have a look at our first example, our curve is going to be kind of stretched, but it's going to be stretched vertically. So as you can see, the distance between the two coordinates, so 2, 8 and 2, 4, is greater. But in our second example, our blue curve doesn't even intercept 2, 8 because it's become skinnier. So it is now intercepting 2, 16. And if you are particularly astute, you might notice that it has increased by a factor of 4, because if we put in a function of 2x, we're going to get like brackets 2x squared, which is like 4x squared, so that's why. Okay. Moving on to our other types of transformations. So, sorry, actually sticking with our our dilations. So where we have our blue curve has now been stretched by our half out the front. So because the number that we're adding in or dilating by is now between 0 and 1, the effect has changed. So it has now become kind of like wider. Getting onto our transformations. So our transformations of reflection, sorry. So if you put a negative outside of a function, outside of our x squared function, remember it's going to be reflected in the x-axis, because whilst the x values of the function are staying the same, whereas before in our last examples they weren't, the x values are staying the same, but the corresponding y values are now all negative compared to what they used to be. So it's going to be reflected in the x-axis. Okay, so now we have another example. So we've been asked to sketch f of x for 2x plus 3. So remember, this is just a linear curve, a linear function. So we just need to find the x and y intercepts. And our y-intercept is always going to be our plus c value on the end. And our x-intercept is going to occur when y equals 0. So we're going to let y equal 0, and then we're going to rearrange our equation to isolate x. So from this, we know this is our function 2x plus 3 with our intercepts put in. Now, however, we need to sketch the function of negative x. So this is another reflection. Now, as you can see, this is kind of not something that we've gone over. So we've gone over where you put a negative out the front of the function, but where you actually make x negative is kind of a different type of reflection. So before we were reflecting in the x-axis, but if you change the sign of the x value, now you're going to be reflected in the y-axis. And that's why, well, that's rather because all the y values are staying the same, but the x values have now been switched. So the value of the function when x is equal to 0 is still going to be 3. So our intercept is still going to be the same, which is important. However, the x value, if x is 1.5, then we're going to have 2 times 1.5, which is 3, plus 3, which is going to give us, my laptop is having a mental breakdown. So if we make x negative 1.5, then our curve is actually going to be equal to 0. And of course we can see on our second graph, that is where we have the x-intercept. So as you can see, the function has been reflected in the y-axis when the x is made negative, but the function, as we went over before, is going to be flipped or reflected in the x-axis if the negative is out the front of the function. Okay, so getting onto our horizontal transformations. So remember, when you add a constant in within the x for a function, you're going to cause a horizontal shift. So looking at our regular function here, if we add 3 in with the x, it is going to be shifted left by 3 units. And that's because if you have a think about what that 3 is doing to the curve, if our x value is negative 3, then our function is now going to be 0, which is what you can see down here. Whereas before, the 0 occurred at y equals 0. If our x is negative 2, then our function is going to have a value of 1, and so on. As you can see, if you add a number to the x in with a function, then you're going to be shifting it left by that number of units. Getting onto vertical transformations. So remember, if you add a constant to the end of the function, as in not in with the x as we were doing before, but right at the end, then you're going to be shifting the function vertically by that number of units. So if your shift is positive, as it is here, we have positive 3, it's going to be shifted upwards by 3 units. And if our constant at the end is negative, it's going to be shifted downwards. So as you can see, if we fill in this table of values, when x is equal to negative 3, the curve is going to be equal now to 12. And if x is equal to negative 2, then y is going to be equal to 7. If x is equal to negative 1, then y is going to be equal to 4, and so on. So as you can see, For every value of y, we're always adding 3 onto the end, which is going to result in that vertical shift.